All right, so each different. Can you, Ethan, help us read that first paragraph? Each different form. Thank you. Last night, look at the forms for me. Last night, guess which form you practiced? The vertex form, okay? So just like in its name, students, the vertex form will show you what immediately? Last night. Yeah, vertex, right? Shows us the vertex immediately, which is always what, comma, what? H, comma, K. Perfect. Okay. Now the standard form, kind of like the line, right, guys? We did the standard form yesterday's warm-up, and you saw it today as well. In the line linear format, it's ax plus by equals c. In the quadratic format, can you guys see that also ax squared plus bx plus c equals y? Okay, so here's the standard form. Now, the standard form, students, will show us, anybody want to guess? What are we going to find immediately? What's easy, you think? Not the vertex, right? But what? Grace? The slope? Not really, but what happened when we plug in 0 for x? What would you get immediately? If we plug in 0 for x, what happened to this term when we plug 0 in? Yeah, right? So if we plug 0 in for x, students, what's the only thing that's left? C, you're right. So shows us the Y-Intercept, okay? And Y-Intercept is when x equals to 0, and we plug in 0, we get C. All right, guys? Now, the next form is called the Intercept Form. And the Intercept Form, students, will show us the, not the Y-Intercept, but the, yeah, shows us the X Intercept. Sometimes we have 2, sometimes we have none. Intercept fairly quickly. Now, X Intercept is when Y goes to what? 0. So I'm going to take this equation, students, and set Y equals to 0. And hopefully you guys will check it out of how we. Now, the intercept form, students, oftentimes you're going to hear me say factor form as well. Okay, so AKA factor form. So if you see me or hear me say factor form, it's the same as intercept form. Okay, so intercept form, just like in its name, we can find the intercept fairly quickly. Once it's factor, we take each factor and we set it equals to 0. So 0 equals A. Well, let's talk about the value of A. Can A ever be 0 in a quadratic equation? So think about it. No, because what is 0 times anything? 0. So that's no longer, it's no longer a quadratic equation. So this would always be ignored. A may never be 0 in a quadratic equation. Now the second factor, we take it and we set it equal to 0. And remember, we're looking for the x-intercept. How do we solve for x if we're looking for the x-intercept? What would you do? What would you move? What would you get rid of? The R1, yep. R1, student, is just standing for if we were to have the first root, okay? So we add R1 to both sides. So our first x-intercept is whatever this R1 is. Second x-intercept, we take the second factor. We set it equal to 0. Very similar, we're going to add R2. Then if we have two x-intercept, then these would be them. Okay, and x-intercept, we write it as, okay, R1, comma, 0, and then R2, comma, 0, because x-intercept is when y equals to 0. R stands for root. Root is the same as the x-intercept. Okay, x-intercept is when it touches which axis? X intercept. When it touches or crosses which axis again? X. Right. Okay. Now, so those are the things we can find, quickly. Oh, it brought me to the top. Come on. Okay. Now on the vertex form, since we did this for homework last night, how do we find the vertex on vertex form? Just simply locate what? H and K. To find the vertex, find H and K. Now every single, guys, parabola will have a vertex. On standard form and factor form, it's not as easily as the vertex form, but we will explore those, okay? We're going to do the examples first before we spell this out. All right, let's go and do examples first. Let's read the guidelines here. Steps to graph any quadratic functions. Here we go. Number 1, Juliana, help me read number 1. Good. Determine which form? Vertex form, okay, standard form, intercept form. Lonnie, help us read number 2.
Find and plot the vertex H, K using the information in the table above.
Okay, find and plot. Kyle, number 3, please.
Identify and draw the axis of symmetry.
Perfect. Lauren?
Make a table of values for the
Good. Sophia?
list the transformations from the parent function.
Right, so guide transformation will come from the A, H, and K value. Chris, next one.
List the transformation.
Oh, 6, hun, 6.
Making a table of values using the transformation.
Yeah, so the parent, it used to be X, we add or subtract H, and the parent's Y, now we multiply by A, add or subtract K. Keely, 7. And then 8, Brad?
Find all defining characteristics.
Okay, we won't do that until 2-7. Okay, perfect. Transformation refresher. Let's spell out the vocabulary. If A is negative, how should we state this on the quiz and the test? Good. Reflect over x-axis. If an absolute value of A is less than 1, for example, a half, 3/4, 8/11, what kind of transformation is that? Vertical what? Compression, right? Factor. If it's a half, then it would be factor of a what? A half. If it's 9/11, then it would be vertical compression of 9/11, right? Whatever A is. How about if A is bigger than 1, like we saw today, 3 and 5 and 2? What is that? Stretch. What kind?
Vertical stretch.
Yep, vertical stretch. I'm going to spell VS. Are you okay with that? V.S? On your homework, you can do V.C for vertical compression. You can do V.S for vertical stretch. Factor. If it's 3, then you write factor of 3. If it's 5, then you write factor of 5. So whatever A is, okay? Factor of A. The H and K. If you have a positive H, what direction is that? Right or left? Right. If you have a negative H, what direction is that? Left, yeah. Then K, if we have a positive K, Hannah, what direction is that, Hannah? Up. Tyler, if we have a negative K, Tyler, what direction is that?
Down.
Perfect. Awesome. All right, let's go and do example 1 to 4. All right, Emma, read the instructions for examples 1 to 4. Perfect. All right, guys, so last night we already practiced your vertex form. So as you can see, examples 1 is not vertex form. Example 2, not vertex form. 3 and 4, not vertex form. So today we are practicing the other 2 forms, okay? So 1, y equals a negative, and then open parentheses, x minus 5 times x minus 1. Out of the 3 forms, which form is this? Yeah, the intercept form. So we are going to go and look for the X intercept immediately. X intercept is when y equals to what? X intercept, Cameron, is y equals to? Good, right there. So we take the equation. We set it equals to 0. So 0 equals negative 1 times x minus 5 times x minus 1. Then we are going to take each factor and we are going to set it equal to what? What did we take and we set it equal to? Take each factor and set it equal to what? To 0. So Val is negative 1, which is in the front here. Is that ever going to equal to 0? No, so we ignore it. In the middle factor, x minus 5 equals to 0. Then the last factor, x minus 1 equals to 0. In the middle, Parker, how do we solve for x if we have x minus 5 equals to 0? Good, add 5 to both sides. So our first x-intercept, Parker, is at x equal to what? 5. We are going to go and plot it. Should we plot x equals 5 on the x-axis or y-axis? X or y? Annalise, x or y? The x, yeah, because it's x-intercept. X equals 5. Now the next factor, okay, x minus 1 equals to 0. So Annalise, how do we solve for x for that last factor? You're so close. We're going to not subtract, but? Yeah, so the second x-intercept is going to be at 1. We're going to plot it. Okay, so think about this, guys. What shape are we hoping to make? What shape? Kyle, what shape are we going to make? Remember, all quadratic functions will make what shape, students? A U, okay? Now, let's go and look at this. We have 2x intercept. Let's find the a value immediately. What's the a value immediately without any work? Negative 1. It's always in the front, okay? This format does not allow us to find h and k as easily as the vertex. But now we do know based on our 2x intercept. Students, where is the axis of symmetry? Where is it? Right in the middle, right, Cam? It's right smack center. If we know, students, the 2 x-intercepts are there, count the boxes for me. Is this smack center? Yes or no? And that is the axis of symmetry. That is at x equals to what? 3. We have the axis of symmetry. Look at that. If we have the axis of symmetry, students, what is the h value? 3. So the only thing we have to do now is find the k value by plugging it in. So students, take the h value of 3 and we're going to plug it into the equation to get the y value, okay? All right, let's plug it in. Here we go. There's a negative in the front. That's a negative 1. And then we go 3 minus 5 times 3 minus 1. So Jake G, what is 3 minus 5? Good. And then Dylan, what's 3 minus 1?
2.
Good. So Dylan, multiply that out for me. Negative 1 times negative 2 times 2. That's going to be 4, okay? So student, k would be what? 4. That's right. Do we now know the vertex? Yeah, 3 comma 4. Plot it. Now we connect them because we have all the dots that we would need to make a nice graph. We do have a nice 3 set of transformations, okay? So the negative a, Devin, what kind of transformation would you state for negative 1 right there? Reflect over. Good. Reflect over x-axis. H being 3, Tanner. How do we state that transformation? Zoe? Oh, did I plot it wrong? Oh, sorry. Can you guys see I plotted negative? Woo, don't do that. Sorry. The math is right. I just plot. Thank you, Zoe. Okay, my bad. Sorry, I plotted upside down. All right, so reflect over the x-axis. Tanner, H is 3. What is that transformation?
The right 3.
Yep, right 3 units. And then Grace, K being 4. What kind of transformation is that?
Stretch of 4.
Not stretch for K. Remember K?
K is, it moves to the image up and down.
Yep, so that would be up by?
Up by 4.
Good, up 4 units. Beautiful. Okay, A, H, and K, those are the 3 things that you would need to state the transformation. So when it is in the factor form, aka intercept form, we would find the vertex. Now we're going to go back and spell it out, okay? When it's in the factor form, to find the vertex, what did we do? Step number 1, what was the method to find the vertex? It's not as easy as H and K form, but we still found it. Sam, step number 1, what did we do first?
First we set the x minus x minus 1 to 0.
Yep, find x-intercept, right? Find x-intercept, and they are always x equal to R1 and x equal to what? R number? What's the other? 2, yep. They're not all the time that we would have both, but okay. Once we found the x-intercept, we plotted them, and then do what? What's the next step after finding the x-intercepts and plotted them? What else? We went and found the axis of symmetry, right? Next is find axis of symmetry, which is x equal to h. And how do we locate that? On the right of the intercept, on the left of the intercept, or right smack middle? Middle, in the middle, okay? Middle of intercepts. Okay. Well, we got the h value now. How do we get the k value after we found the AOS? Sam?
Plug in the h into the x equals 1.
Yeah, plug h value into the equation. To find k, okay, aka y. Okay. All right, guys. We're going to go do example 2. If you scan on example 2 on your packet, what form, Holden, is example 2 in? Yeah, it is totally in standard form. So it's not exactly the same as your your factor form here. So let's go and, no, am I going too fast? Oh, yeah. Where do you want me to go? Right here?
Yeah.
Okay, yeah, for sure. Sorry. Okay. All right. Okay, so standard form. Here we go. Example 2. F of x equals 3x squared plus 12x plus 10. We could technically factor this out, right? Can we technically factor this out and put this in factor form?
Yeah.
Oh, yeah. Okay, so that's one of the ways. Now, another way that we can find the vertex in standard form is using this equation. Okay, vertex, x coordinate of the vertex is negative b all over 2 times a. I'm going to highlight this. Well, in standard form, what's a value for this example? What's an a value for this example? What?
3.
Yeah, guys, a value, we can always find it. Doesn't matter what form it's in. So this is a, 3. B is how much? B is 12. C is? What's C? Did you say 10?
Yeah.
Okay. Would you guys agree earlier we mentioned that if it's in standard form, we can find the Y-intercept pretty darn fast? Y-intercept is when all of the x's disappear. So what is the Y-intercept? Yeah, so we can find it pretty fast, okay? If we know the Y-intercept is 0, 10, can I plot it right away? Is that okay to find? Yeah. Well, one dot's not going to help us out. We need at least 3 dots to graph our parabola. So we're now going to find the vertex. The vertex is opposite of the b divided by 2 times a. In this example, what is b? 12. You're right. And opposite of that would make it a? Negative 12 divided by 2 times, what's a? 3. So negative 12 divided by 6 would give us negative 2. That is the x coordinate of the vertex. Would make it which one? H or K? H. Well, how do we get K? Plug it in. Yep. Let's go and plug it in. Here we go. When H is negative 2, plug it back into the original. 3 times quantity of negative 2 square plus 12 times negative 2 plus 10. That's you. Well, negative 2 square is what? 4. 4 times 3 is? All right. Plus 12 times negative 2 is? Negative 24? Plus 10? Someone verify that basic math for me. Does that look okay? 12 and a minus 24 would be now a minus what? 12 plus 10? Negative 2. So, whoa, then what's the K value? Negative 2. So would you guys agree the vertex is at negative 2 comma? Negative 2. So I'm going to go negative 2 down here. That's the vertex. Yes, no, maybe? Okay. Well, I have 2 dots. We know that this is a parabola. We know A is positive. We know A opens up. Do I need to do any more work to find the third dot? No. Where would we plot the last and third dot? We have negative 2, negative 2. The third dot will be negative 4 up. Exactly. Right? Okay, and we also have every single thing we needed to fill out our chart. So Haley, axis of symmetry, we would write what, hon?
Negative 2.
You're so close. We want to write what?
X is equal to negative 2.
Exactly. We would have 3 transformations, okay? The 3 in the front, Tyler, is what kind of transformation? Consult with your team and come back.
Vertical stretch of 3.
Good. Vertical stretch factor of 3. Good job. The -2 for H, Sibby, is what kind of transformation?
For H,
Yep.
left 2.
Very good. Left 2 units. And then, Anna Sophia, the K being -2 is what?
Down 2.
Down 2 units. Beautiful. Okay. Now we're going to go back to the original definition box and fill out the steps of how to find the vertex when it's in standard form before we go to example 3 and 4, okay? So once you are done copying this down, we'll scroll back up. Uh-huh.
How do you get the 2 points on the top of the graph?
2 points. Like the orange dot? Okay, good, yeah. Guys, can you guys tell me how we get this Y-intercept? Y-intercept is when x equals to what? Great question. Thank you. 0, right? So x equals to 0. So we're going to go into our equation, and every time we see an x, we plug in 0. So 0 squared times 3 plus 12 times 0 plus 10. What happened to those terms right there? They disappear. So that's why we have a y-intercept at 0, 0, comma 10. Is that okay? That's a really good question. Thank you. Any other questions at all on standard form? We'll go back up to the box and spell that out, okay? All right. Standard form. The box in the very top definition, which is for you guys on the other page. Step number 1. How did we find the vertex? What did we do? To find the x coordinate of the vertex, we use what? What did we use? X equals what, y'all? No, what's the formula that we use to find the x coordinate of the vertex?
Negative b over 2a.
Negative b over 2a, yep. Well, then how do we get the y coordinate of the vertex? Yeah, plug it in to get the y coordinate. Of the vertex. Okay. We'll leave it there for you guys to copy. So there are different ways to find the vertex. Would you guys agree? What's the easiest way? I mean, what's the easiest form, by the way? Yeah, straight up, for sure. I would do that all day long. Okay, we have 2 examples. And the last 2 examples are practicing again on the newer form. All right, Ian, what form is example 3?
Example 3 is Intercept Form.
Yeah, let's go do it. So Ian, a equals what?
A equals 1.5.
Perfect. So we are going to find what first easily? What can we find first easily?
The X-intercept.
Yeah, X-intercept. Set the whole thing equals to 0. So 0 equals 1/2 times x minus 2 times x plus 4. Students, is 1/2 ever going to be equal to 0? Yes or no? No, so we ignore it. Then we're going to take the next one. X minus 2 equals to 0. X plus 4 equals to 0. Okay. X minus 2, Ian, equals to 0. So our first X intercept is at where, Ian? Yeah. Second X intercept, Ian, is at where? Perfect. Let's plot it, okay? 2 and negative 4. Where is smack center? Yeah, do you guys agree with Ian? X equals negative 1. So AOS, we write what, Courtney?
Negative 1. X equals negative 1.
Yeah, much better. X equals to negative 1. Perfect. Now, do we know an H value? So what is the H value, Zoe? H value. H value. Yeah. So now that we know H, Holden, how do we get the K value for the vertex?
Plug in -1 for every X value.
Yes, let's do it, y'all. -1. Let's plug it in. 1/2 is in the front. -1 minus 2 times -1 plus 4. 1/2 in the front, drop down. This is going to be -3. -1 plus 4 is 3, right, guys? -3 times 3 would give us -9 times 1/2. Yeah, -9/2 or 4.5. Is that okay? -4.5. All right. So K is -4.5. Do I have enough to plot our vertex? Yep. -1, -2, -3, -4, -4.5. Opens up or opens down? Up or down? Up. Okay, we got it. Let's state the transformations. There are 3 total. All right, Grace, A equals 1/2. What is that transformation?
That means it's gonna be compression.
A vertical compression, factor of how much?
1/2.
Perfect. Are you guys okay with me writing V dot C? Okay. H, Tanner be -1. What kind of transformation is that? Left, yep, left, 1 unit. And then, Devin, K be -4.5. What kind of transformation is that? Down 4.5, yep. Now that we've done the second example, is it as bad? Not really, right? Okay. All right, Dylan, example 4, last example of today. What form is that in, Dylan? Right, standard form, y'all. What can we find quickly? What can we find quickly? Yeah, y-intercept, students, is when x equals to 0. If x is 0, x squared is gone. 4x is gone. Right, guys? What's left? -5. So I'm going to go and make a dot at -5. So 0, -5. Bam. Okay. Jacob G. What is the A value for example 4? -1. A, it's always easily found. Doesn't matter what form we're in. Well, snap. I need H, I need K, which is the vertex. When it's in standard form, how do we find the vertex? What's the formula to find the x coordinate of the vertex? Right. So -b divided by 2 times a. Look at our equation really quickly. Annalise, what is the b value of our example 4? 4, so we're going to do opposite of that. So it's going to be negative 4, right, students? Divided by 2 times. We just got done listing our a. What's our a value? Negative 1. So negative 4 divided by negative 2. The x-coordinate of the vertex is 2. All right, that goes where? H or K? H. How do we get K? Plug it in. All right, let's go. We're going to plug it in. Y equals, we know H is 2, so the negative's in the front. Quantity squared 2 plus 4 times 2 minus 5. Okay. 2 squared is 4 times the negative in the front will give us what? Negative 4. 4 times 2 is 8, and then drop down the 5. Negative 4 plus 8 is 4. 4 minus 1 is what is it? 4 minus 1? Negative 1? And what is that? HK or A? K. So do we know the vertex? What is it? 2, negative 1. We plot it. 2 is on the right, negative 1's right here. Okay. All right, guys. I have 2 dots. That's not enough to graph my parabola. So how do we get one more dot at least? Where do we go? Where do we go to get the very last dot? Remember, this is the vertex, which is also AOS, right, students? Where do we go to get the last dot? To the right or left of AOS? To the right. You guys remember it's symmetrical, right? Do we go upward or downward? Downward, because A is negative. Okay. Let's fill out the rest. AOS is, what is our answer for axis symmetry? X equals to 2. We have 3 transformations total. A being negative, meaning, yep, reflect over the x-axis. H being 2 is to go right, how many units? 2 units. K being negative 1 is to go down 1 unit. Out of all 3 forms, is this pretty bad? Not really.